So you're not, okay, so look, you're not supposed to be using the calculator, okay? Bye. All right, you're not supposed to be using the calculator, but if you guys want to grab a calculator to make sure you're doing it correctly, so I know we already did this, but it's Monday, so I'll hurry up and get to another one. Negative 510 degrees, you get negative rad 3 over 2. Okay, so that's the answer I should get. Now, the way you're supposed to do this, okay, is, so, okay, this is a second revolution, right? Remember, 0 to 360 is one spin or one revolution, right? 360 decimal, right, to 720 is 2 spins. So if I take, right, we already did this, so I'm just going to make it quick. So negative 510, if I add 360, I get negative 150, right? So that means negative 150 means that if I grab, so because it's negative, I'm going in the negative direction, which is, right, counterclockwise. So negative 150, there's 90. And so this is negative 150 degrees. And so the reference angle, okay, so this is 90. That means this is 60. So then this is 30 because every quadrant is 90 degrees. I realize that's so far away. So far, so good? Okay, so if I look at that 30-degree reference triangle, and if I pull it out just because it looks a little smushed, 30 degrees is here, 60 is here, because I know I put it here. I don't want you to think that that's that vertex angle. It's this one here, right, off the origin, the opening. Okay, so then this is 2 rad 3, 1. I want cosine, so that means this is, if this is my 30-degree angle, this is opposite adjacent hypotenuse. But so far, I've made an error. What is my error that I left off? It's not perfect. What's wrong with it? And by the way, as a student, I was notorious for this. I always had to be like, go back and look at your work. What did I mess up? Now I'm supposed to teach you guys. What did I mess up? It's not perfect. What's wrong with it? Very good. Yeah, yay, Victoria. Okay, the negatives. Remember, if this is positive, positive, this is negative, positive, this is negative, negative, this is positive, negative, right? So I'm going back on the x-axis and down the y-axis. So rad 3 is negative and 1 is negative. Yes? Yeah. I was so good at always messing up the little negatives. Okay. So now what is cosine? Cosine is, right, CAH. Cosine is the ratio of adjacent over hypotenuse. And so I get A over H, and I get negative rad 3 over 2. And that's what the calculator gave me, negative rad 3 over 2. Okay. So yes, you can use the calculator to verify your work, but ultimately that unit circle, it does take time, but you just kind of want to you get faster once your head gets into the spins, and it's the best way for you to master your 1, 1, rad 2, 1, rad 3, 2, and then your SOHCAHTOA. Coterminal angles just solidifies those like concepts together. And then as far as the radians, most students, 80% of you guys change it to a degree and then move from there. And then some of you guys get pretty good at the radians on how to cut it. I kind of figured that out from Friday, who was good with radians. And so, you know, you do you. Okay, yes? Okay. All right, so then let's just do one more. We'll just make the video long. Okay, which one? 3 through 8. Which one do you want me to do? Obviously, I would say go to another quadrant than 3. So what do you want? Not 1. This is... 7. Oh, okay. Quadrantal angles. Okay, so it's an angle that sits on the quadrant. Okay, a unit circle Remember, it's called a unit because it's one. It's one unit. Like, hey, do you want a water bottle? Like, oh, do you have a car? Right? So it's a unit circle. So that means unit being 1, 1, 1, 1. So this is 1, 1, negative 1, negative 1. So if you guys look at your coordinates, this is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Kind of? And that's your unit circle. And that's the yellow paper you're going to get today. Okay, that's an ugly unit circle, but it's supposed to look like that. Okay. Yes? Okay. So if I'm here and I spin around and you look like you're on 3 revolutions, it's stopping here on this quadrantal angle, which is here, which is here. Yeah? Okay, so if you guys look, cosine is the first, sine is the second. Think alphabetical, C before S, like X, Y, your component. So what is sine of what's sine of 990 degrees, which is really 270 degrees on a 1 spin. So what'd you guys put? Your answer is like right here in pink. Which one? Oh, what'd you say? I want sine of 270 degrees, right? 900 if you're on 3 spins, 270 if you're on 1 spin. That location, there's no 30, 60, 45, yeah.
Oh, 0, negative 2.
But I just want sine. What would I write here? What'd you say?
Sine of 90.
Sine of what?
90.
No. It's this is actually 270. 270 is from here to here. So what would I write? Huh?
Wait, sine of 990?
It's the coordinate. But which one? Which component? Yes. It's just negative 1.
Oh, because you're only measuring 270.
Okay, wait, it's okay. So look. So sine of 990 degrees is just negative, is negative 1. Okay, so, but that's 3 spins. Sine of this first spin is 270, it's still negative 1. Why? Because it lands here at 270 degrees. 270 degrees is a quadrantal angle. The location of 270 is 0, negative 1. 0 is cosine of 270. So 0 cosine of 270 degrees is 0. Sine of 270 degrees is negative 1. So then if I asked you what the sine of 990 is, it's this coterminal angle down to spin 1. Kind of? It's okay, you guys, because eventually you're going to get tangent. We're going to work with tangents. So like here on the 90, let me use a different color. Sorry, this video is going to be like really long. Okay, so this 90 degrees, it's on a first spin. You're landing here, so you're landing on this coordinate point. Remember, this is cosine theta. This is sine theta. So what is it looking for? What is the sine of 90 degrees? What am I going to put here? 1. Very good. Look at you guys are so quick. Okay, let me finally turn this off. It's long. Okay, let it load, and then I'll tell you guys about the unit circle.